how to build your own chiller? Today is DIY chiller video. I built a chiller and I did it so that I could cool the water in my grow bed. Why? If I regulate that temperature, then I don't have to regulate the ambient temperature as much. Now the reason I did the chiller build is because not only do I have to keep the water cold, but I also have to buy 3 more tons worth of air conditioning for the building because of the lights and the load of the structure. It equals 6 tons. I only have 3, so it was cheaper for me to build that chiller than it was to buy a new air conditioner. Now, I had most of the parts and I only spent about $100 in materials. I actually had everything else. In this video, I'm going to explain to you how to build your own chiller, what parts and components I used, and then if you want another video on the wiring, I will do an explained wiring video for you guys that are actually going to do this. Now, if you want me to build your own chiller for you, then I can do that. A 2-ton industrial chiller, I looked it up, they were all out of stock, so I couldn't get one, and it was about $8,000. Now, if I was to build this chiller, I think I could do it for around $3 grand. And if I was to build it from scratch, I could do it for cheaper. So today's video is all about building your own chiller, and you can build it whatever size you want, from 1.5 ton upwards of 5 tons. And you can get a really, really beneficial way of chilling your water. And I really want my water to stay about 65 degrees. So I've got a controller that helps me to dial that in, and it's got a differential setting, and I'm going to show you all that in this video today. Thank you so much for my members. This is a members only video. I want to give you the best content that I can, and if you like it, definitely hit the like button. Comment below, let me know what your questions are. Share this video so that other people know what I'm doing. I really appreciate all of my members. You rock. Thank you so much. So first things first, I am going to show you the PE pipe. There are 3 rolls of 100-foot pipe inside underneath the water column, and I'm going to show you. It's 3/4 inch pipe, it's PE, and you get it off Silverline.com. And this is a closed loop system. It's all closed, from the chiller to the coaxial to the pump to the plumbing, and then to those loops. Those are slinky loops, okay? Nothing's wire tied. If I wanted to sink it down in the bed, I use these half cap blocks, and you can actually put pond liner underneath, which I've got pond liner right here, so that I can make sure that none of that brick eats through my pond liner in here. Because I got a 20 mil pond liner in here, but I don't have to. I actually just sink it in the water, fill the loop up with water, and then it goes right underneath my rafts. Now the plumbing, there is 3 inlets and 3 outlets, 3 supplies and 3 returns, and it's all 3/4. All 3/4 with a coupling that is thread to slip, and I got a 3/4 to 3/4 bar fitting, and I did a hose clamp. I also did some PVC glue in there to make sure that it stays. And then I did Teflon tape because the PE pipe and the 3/4 barb, it didn't fit just right over that. So I just want to explain that before we move forward and I actually turn the chiller on. I'm going to show you outside what it looks like. I wanted to show you the plumbing though. All 3/4 pipe, there is 1 there. There's 2 fittings there, 2 fittings here, and 1 fitting there. And then this is 1 coil. Goes in here, 1 coil goes in there, the other coil goes around and goes in there. All right, and when I turn on my chiller, the water that circulates through the loop goes from 70 degrees to 40 degrees quick. All right, and it's all controlled by the pump. You see, the faster the pump flows, the colder, the warmer the water gets. The slower the pump flows, the water, the colder the water it gets, okay? And that's why this is a 1,200 gallon per hour pump. Really too big, okay? I need about a 300-400 gallon per hour pump. This is a 1,200 gallon per hour pump. It's all I had, but it worked because I closed it off. Now, do I recommend this? No, because you actually affect the longevity of the pump. You affect the efficiency of the pump. The more restriction, the more resistance, the more amp draw, the less the life, okay? Get a pump that's sized properly, okay? And if you don't know what size, go big and then cut it off, okay? That way you at least get the temperature difference you need. All right, hold on. So the slower the water, and I'm gonna actually explain this outside when you see the coaxial. Okay, the slower the water flows, the more heat that is absorbed, and that's going to make it colder. And the colder it gets, the more temperature difference you have, the faster it cools the water off. Let me show you the control. We'll turn the chiller on, and then we'll go outside and I'll show you what else. That's a 110 volt pump. This is the wire for the pump. This is the wire for the sensor. This is the wire to the chiller. Okay, thermostat wire, 18 gauge. It's this is the sensor. Okay, I've got it wired there. It comes down, it goes all the way over, and it goes to my control. Okay, this is the control. It's displaying the temperature. It's 67 degrees right now in the water. All right, and I'm going to show you so you guys see it. This is the sensor. Okay, this is what measures the water temperature, and I put it downstream so that as the water cools, the water flows this way and I'll get a good reading. That's my outlet. Okay, my inlet to my grow bed's down there. If you want to know more about how I built the grow bed, go check out the other video on how I built this aquaponics system, what it's made out of. All right, now note for turning on the chiller, let's go through some things here. So if I push set, it shows me Fahrenheit. My set temperature, I'm going to go to 65. I'm going to go to 1 degree differential. That means that when it gets to 66, it'll turn back on. And I can set it for 3 degrees, 4 degrees, 5 degrees. That means it'll, when it gets down to 65, it shuts off. And then when it rises 5 degrees, then it'll go ahead and turn back on and it kick it back down to 65. All right. All right, let's go ahead and turn it down to 65. All right, 65, 1 degree differential because we want it to actually kick on. All right. All right. When it kicks on, pump starts flowing. Let's go outside and check out the chiller. If you have any questions about how I built this chiller, if I didn't do this video justice in giving you all the information that you need, let me know. Again, if you were to build this chiller and it was an industrial chiller, it would cost you $8,000 to order one. If you were to build it, it'd probably be about 3 or 4 grand. And that just depends on manufacturing. That depends on who the brand of equipment is that you got and what you paid for it. All right, now let's go. So it's not pretty. I was gonna put the condenser up top and then turn the coaxial on its side and have it all kind of, you know, up and down, right, you know, where the coaxial will be right underneath and there'll be a stand the condenser sets on. That's ideally what you want to do. Another thing you want to do is you want to have a titanium coaxial and you want to make it an open loop. Okay, that means you don't have those slinky loops inside. You actually circulate the water from the aquaponics system through a filter into the coaxial and then back out. The reason I did closed loop is because I got this coaxial for free. Okay, this coaxial could cost anywhere from $500 to $1,000, but I got it for free. Now I'm going to explain to you what this is, how I set it up, and how it works. This is a 2-ton heat pump condenser. All right, it's made by York. If you were to get this, it'd be, you know, $1,500, $2,000, something like that. Not that bad, right? If you were to buy a coaxial online like this, which is a copper coaxial, then you would be buying, it'd be anywhere from $350 to $1,000. This is a TXV. It's a 410A TXV, and it's a sweat end. It's not a compression, it's a sweat end. This is a filter dryer, and this unit was damaged. That's the reason I got it for free. It needed a new compressor and a bunch of pipes, and I actually put a new compressor in it. It didn't have any boards or anything in it. I actually had to pretty much build it from scratch, right? Except for the outdoor fan motor and the coil. So what I did was I tied in the suction line, okay, into the bigger line of the coaxial, which is about the same size as this tubing, which is 3/4 tubing. And then I've got 3/8 tubing here, which is the liquid line. And I've got it going into the TXV and then entering in to the coaxial, okay? And the way this flows is, it flows from the liquid line, okay? into, it flows in from the liquid line into the coaxial, and then it boils off. This is the evaporator, and then it comes out of this a low pressure vapor, and then it goes into the condenser. So where you would have an indoor coil, you have a coaxial, okay? So it's basically a split system. This is the indoor air handler, okay? This is the indoor air handler. If you're an HVAC technician, this is what you call the indoor coil, the evaporator. So you'll know what I'm talking about. This is the outdoor unit, this is the indoor unit. Very, very simple. I've never done this before, but it's very simple. Now, this is the inlet and outlet pipes, the return and supply. This right here is a little valve that I put, a little spigot, a little hookup so that I can add water and so that I can check pressure. I'm going to show you how I check pressure on this. And the reason you want to check pressure is because these things matter to you. Just like checking the refrigeration's pressure to make sure that I have a good suction and discharge, just to make sure that I'm not affecting my compressor. I have high head pressure or I have low suction to where I'm freezing up. I want to make sure that I check everything. So that's the reason I put that little spigot there, so that I can put a gauge in line and check and see what the PSIG is. And right now it's 40. Also, so that I can isolate the coaxial. If I ever want to take this apart, which I will, I'll be able to do that. So all you have to do is you buy a Ranco electronic temperature control. You buy a heat pump condenser, which you can just buy a regular condenser. You don't have to buy a heat pump condenser. A regular condenser, get a little bit of 3/4 and 3/8 copper. That's if you want 2 ton, and then match it with a 2 ton coaxial. I'm going to show you guys online where I got all this stuff, and well, where you can get all this stuff. Let me show you how I check pressure. And again, you don't want to do a closed loop. Let me tell you why I did a closed loop. Okay, and I think I've already told you, but I'm going to tell you again real quick. The reason I have a closed loop is because I got this off of an old unit, and it was with a well. It was a geothermal unit that had a open loop that was pulling from a well. And this coaxial is about 10 years old. Although when I drained it, everything was clear and clean. I took a flashlight, I looked inside, there wasn't a bunch of scale buildup. So the water from the well was pretty good water. So, but I don't want to do an open loop with this because it's over 10 years old, and what if it leaks? And what if I get refrigerant inside my aquaponics system? Now, if you use a titanium coaxial, then it's going to be a little bit more resistant from the water that you're pulling in, and you need to make sure you have a filter. That way you're not pulling in your sediment from your aquaponic grow bed. You want to make sure that you keep any of that away from the coaxial, because you'll stop it up and then you won't have good heat exchange, okay? You want to make sure you have that filter. You want to also do a titanium coaxial. You want to put your condenser up on a stand, so that means weld a stand, and then put the titanium coaxial underneath, okay? It'll look better, it'll be more presentable, look professional, and then you can just have your water lines go out from underneath your condenser. So I think that'll be much better. We're going to talk about the wiring in just a second. First, let me show you this little bitty pressure gauge that I use to measure the pressure. So this is the type of gauge that I'm using to measure the pressure. I just put it on here, screw it on, and then I open up the valve, and then I can measure the pressure. It's good to have one, you know, maybe in the pipe. That way you don't have to do this. But I didn't want anything like that. I just wanted something quick that I can attach so that I can read the pressure of the water. You can find them at your plumbing store, and you'll be able to check pressure. I like to check pressure. I like to use a temperature probe and connect it to my meter and go in here and measure the PE pipes, because I want to know exactly what the temperature is and make sure it's working properly. Now let's talk about the wiring. Real quick, I'm not going to go into too much detail, but first I'm going to show you the pipes and how they're starting to sweat because they're getting cold. See that? Oh yes, that's getting cold, man. It's getting, and it's icy cold. It's so nice, so nice. Oh yeah, see this pipe right here, all 3 of these pipes on the bottom, getting super cold, man. That's awesome. All right, last thing we're going to talk about is the Ranco Stat. The Ranco Stat has a sensor that measures the water temperature, and then it has a power wire that's broken that powers the Ranco controller. The Ranco controller can be 24 volts, 110 volts, or 240 volts. Make sure that you check the model number, maybe the installation instructions or wiring diagrams. Make sure that if you want 24 volt, you get that. 24 volt would have been easier, but this was just as easy. So what I did was I broke the contacts, and when it closes the relay, it sends 240 volts to one side of this contactor, okay? And because this is a 240 volt coal contactor. And when it closes, I've got a thermostat wire here, right? And this thermostat wire breaks the red to the condenser, okay, outside. And that condenser, it calls for the 24 volts and energizes the reversing valve, and it runs in cooling. This right here breaks one line of the wire right here. You can see this right here that goes to my pump, okay? So it's very easy. I'm basically just breaking the 24 volt call to the condenser, and then I'm breaking the 110 volt call to my pump. Super easy, all right, super easy. I know how to do this more efficiently. It needs to be an open loop. What do I mean by open loop? I mean, you literally take this off, both of these connections, you drop them into the water, you pull your water in, and you push your water out of that coaxial, and this would cool this water twice as good as having those slinky loops with cold water circulate. The only reason I am not doing an open loop is because I have an old coaxial. You do not need to use a coaxial off an old unit because you have no idea what the water was that was being pulled into the coaxial, if there's scale buildup that could come off and go in your system, or the copper leaks and then refrigerant fills up this grow bed, which would be terrible. But open loop would be so much better. Now, I'm gonna show you online where to get everything, and I'm gonna show you about the titanium coaxial. If you wanna build your own chiller, you're gonna know how, and let me know if there's anything I left out. Thank you again, everybody that's watching me. And remember, I'll keep you cool if you let me. And remember, don't forget to water your plants. These plants are looking good, aren't they, guys? Look at that. Look at that. That's awesome, man. And I've got these roots that are coming through now. Look at that. Look at that root. Hitting the net pots. Looks like it's time to scatter all these out, get them set underneath the lights, and start growing them out even bigger. And guess what? We're ready for the garden outside too, guys. We got zucchini, we got squash, green beans. I've got a bunch of companion plants like those marigolds. We've got some oregano. That's right. I'll keep you cool if you let me. Love you guys. Peace. So if you want to build this chiller, I'm going to show you how to look up all the components that you need right now. Let's start with the 410A condenser. Type in 410A condenser, go over to shopping, and we're going to populate here the condensers we need. This is a 2.5 ton Goodman condenser, $910. 3 ton, $1,000. Remember to match your coil, the correct size tonnage coil with the correct size tonnage condenser. All right, this is how you get your condenser, guys. It's very easy. Now we're going to erase condenser, and then we're going to search our coaxial. Now I'm going to talk about coaxial heat exchangers. Type in coaxial heat exchanger. Immediately you're going to see there's a coil that's just like mine right here, copper nickel heat exchanger, 3 ton aquaculture geothermal. You could use this one, but if you want to use something pre-made that's already made for swimming pools, then you can go up to the top, and it says here poolweb.com heat exchanger, and it shows some PVC there. It looks like it's got 2-inch PVC inlet and outlet for the water side. All right, there's another type of heat exchanger. You can use a titanium heat exchanger by typing in titanium coaxial heat exchanger, and those are really nice. I don't see any more down here that we would use except for that pull web there. Hayward makes that. A little bit expensive though. You might want to stick with something cheap. Copper nickel, it would probably last a good 10 years. Definitely need to have a filter. I'm going to show you the filter as well. Let's move on. So 410A TXV. Why do you need a TXV? If you don't have a TXV, you're not going to be able to meter the refrigerant right that's going into the coaxial. You need to make sure that your equalizer tube, which is that little bitty 1/4 inch line, a little bit smaller, looks like than 1/4 inch. It's like 1/8 inch. You need to use that 1/8 inch line, the equalizer tube, and you need to solder it into the suction line going into your coaxial. Then you have a bulb that needs to be mounted right there next to it on the suction line going into, or vapor line going into the coaxial. All right, that is over with, and that's a sweat on, all right? Thermal expansion valve. That's so that you can meter the refrigerant. If you don't have it, it won't work properly. Now, look up Ranco electronic temperature control. We're going to scroll down. You can get one at a supply house for $50. That's how much I paid for mine off Amazon. There's some that range from $50 to $100. It depends on how new they are, and it depends on the control specifications, whether it is 24 volts or not. So make sure you do that so that you guys know where to go for that. All right, now we need to look at the Silverline high density polyethylene pipe, or PE pipe, okay? Polyethylene pipe. It comes in 100-foot or 250-foot rolls. You can get it at Lowe's, or you can go to silverline.com and you can find tubing online. High density polyethylene is great, and you can also use PE pipe. But remember, if you want to do an open loop, that's going to be a much more efficient and better method for doing this. Now, what we're going to look up now is a pull inline filter. And the reason I'm looking this up is because you need a filter, okay? Whether it's a mesh filter right there and you're tying that into your plumbing coming, from your grow bed, or it's another type of filter, you need a filter, especially if you're doing an open loop. You don't want your heat exchanger to scale up like I talked about earlier. You don't want to lose efficiency and your equipment be in bad shape. Last but not least, Tatty Digest. That is the YouTube channel. If you haven't seen my latest videos, check them out. If you want to learn more about anything that I'm doing, stay tuned. I love you guys.